Hi, this is Derek Sills coming to you again with another video. This video is about framing and locations of the windows and doors from the framing layout. Stay with me, stay in tune. Welcome to my channel. Again, we're going over some knowledge about framing. Today's video is going to be very important for you. So I really need you to pay attention to what's going on today. As you can see, we have a lot written out on our board today because there's a lot of information that I do need you to really understand when you get into the framing process. The framing process is a very physical process, and it requires for you to really pay attention to what's going on, especially with windows and doors. You cannot put them in the wrong location or you will have a lot of problems with the exterior of the building or the house, with the exterior of your kitchen, door access. The window locations can throw everything off. So today, when you look at my frame, you're gonna see studs. Studs are regular framing members that is attached to a bottom plate and attached to a top plate. You have a bottom plate, you have a top plate, but you also have a double top plate. The double top plate function is very important because it ties walls together and locks them into place. And they're normally locked in and nailed on the top of the wall and the side or the facing of an intersecting wall running into that wall. So you need to be very aware of the terminology that is used on a construction site dealing with framing. As you can see, I have a doorway here. This door consists of a header. It also consists of a plate that's running through. But this plate is going to be cut out because this is a trip hazard. So once the wall is framed up and all the walls are tied together and everything's plumbed and aligned, which we're going to get into later, you got to cut this piece out here so you have a free flow access through. In this video, we're sharing with you vital information about members of a framed wall. Header. This is a header here over a door. This is also a header here. That's over the door. This is over a window. This header is over a window. Now the components framed for a window is quite different from a door because you have framing members at the bottom to create the frame of the bottom of the window so that the window can set in and have support all the way around its perimeter. This is what you would call the perimeter. So if no concrete, if this plate is on concrete, if this plate is on concrete, it has to be treated. It has to be pressure treated, or it has to be some type of treated lumber that's going to be able to sit on top of the plate. So treated, pressure treated, womanized. In California, they all have a chemical to sit on top of concrete. Now, if on plywood, regular 2x plate is required. Plate material is different from stud material. Your studs is a different grade, the number 2 or better. Plate material is like a number 1 grade. You could tell the difference, and it's going to have a different color coding on the bottom end of the stud versus the studs. The studs may be painted red. Usually your plate is going to be painted on the West Coast green, and they're at a long length. Studs are cut at a shorter length because they're studs for a wall. Plate material, 14 footers and 16 footers is what you want. I prefer 16 because when you do your layout, you want that last part of that plate to be on the center of a stud before you join another plate up underneath. You don't want a plate to have a splice, which means it has an end and there's nothing there. And then you have a stud. So if your plate ends in the center here, then the next plate will join in. And then there will be a 2x half on that splice. You always want that. Even at the top plate, you want that. You'll get called on inspection for that. This has something to do with separation of a wall and you want that wall to be extended, to be a continuous wall. When a wall has a break, and that's what we call a break, when a wall has a break in it, that creates a weak area. You want a stud to come in between the break and separation of both walls. As we go over here to our double top plate, as you can see on our double top plate, there's 3.5 inches in, which means this plate is cut short. Why is it cut short? And why is it hanging longer on this end? This end is a lap end, or what we would call sometimes a horn. The horn laps over. Why? Because there's another wall that's going to come right over underneath this horn. That plate is going to be nailed to the wall that's coming into it. There's a wall coming in over here, but the other wall that's intersecting and coming into this wall, its plate is extended 3.5 inches over like this. So this end for a wall coming into this end is going to be nailed in on top of this wall. That creates where both of those walls are tied together and locked, using 3 to 4 nails, penetrating with your nail gun or sinking them in with a hammer. It suffices enough to keep that wall tied together. Plus, you're going to be nailing through the side because there's going to be a channel. Usually when you see that, there's 3 studs here. I didn't draw them in, but to get the idea, there's going to be another stud, there's going to be another stud. Okay? 3 stud channel is what we talked about before that you're going to need. Okay? And here's the channels. I got them drawn at the bottom. You got a 3 stud channel here. That's solid. It's going to be stitch nailed on both sides. Stitch nail is when you toe on down every so many inches. Here we have this California channel. That's my friend, California. This California channel is also for backing for drywall, or you can call it for a deadwood stud for drywall. Drywall needs nailing at every end. You can notice that I don't have anything on this end, and I didn't have anything on this end until I just created that. So, with that being said, you have a header on the window. You have a seal plate that your window rests on top of, and that's the window seal. Everybody knows what a window seal is because it's usually drywall there, or you have some type of finished wood material as an, apron is on the front, but the window seal has finished material up on top of it, and it's caulked around the window, or it's drywall. Understand one thing: I frame with double seals, not a single seal. You can't frame with a single seal. That's just a way you have really only one seal to nail to. You really want this thing to be really solid. You know what I mean? Framing and your structural part of the frame, you want this to be solid because it's nailed into the trimmer, or the trimmer is nailed into the seals on both ends. This trimmer here goes all the way down, but it stops because it's supporting the header. This king stud, okay? King stud. So let's get that in here. King stud, as I have marked here. King stud, showing you here. Trimmer stud or jack stud, showing you here. Okay? So you need to be familiar with that, because these are major components that hold a window and door together. The king stud and the trimmer stud. The trimmer stud supports the header up underneath it. The king stud supports the header outside of the header. It's face nailed to the header. Above the header, you have cripple studs, your top cripples. These are going to be called top cripples over your doorway, over your window. These cripples are also laid out with the stud spacing. So just because you have one here, I always put one next to the king stud. Just a common practice, okay? You don't have to, but common practice is you put one right over here to follow up underneath the trimmer. It's not continuous, but it makes the framing looks good. But my layout for my stud is always going to continue all the way across. So my stud should be laid out exactly with my bottom cripples on my window. My top cripples are going to be a stud layout every 16 inches before I get to another stud. If it looks a little off, it doesn't matter. The header is its own entity above itself. It's supporting that span between the king stud to king stud. That's where the support is. That's why this opening is able to be there. Same with the window. We have taken away space of studs to create an opening for our framing. So you can walk right in. This is the support over your head. With any type of opening, whether it's an 8-foot, 6-foot opening going into a grand room, great room, living room, you need some type of support. Some minor beams, some big headers. Okay? Same as a garage. When you drive into your garage, there is a garage header, still a header, but it's called a garage header that spans the entire distance in between the little frame walls and sitting there so that you can drive your car in. And that header is supposed to support the roof that's going to bear weight down on that open area because there's no studs there. You have eliminated the studs, so you need to create some support that's going to span the whole entire width of what you're dealing with so that it can support the members above because there's nothing underneath as studs. The header takes weight load and distributes it around to the outside and also supports it in that area where there's nothing there. Double top plate is at the very top here. Top plate is the plate that the stud nails to. Always remember, you have a top plate. Some guys will call the double top plate a top plate. Hey, I need some top plate. Top plate is already on there. Okay, they're not used to, in the South, say double top plate. Okay, they just say, hey, give me some plate. If you know that the wall is framed with a plate on it, and he said, hey, I need some plate, that means double top plate. Because you cannot frame without a double top plate. There are two members that go above your framing studs, and they're plates. Top plate, double top plate. Bottom cripples for your window. Your window must be supported. Your window sill must be supported by bottom cripples. BC. We're going to show you how to calculate and get this size here. And get the size of your top cripples. And get your header size. That's another video. Your seals also going to be on that same video. There's going to be a layout that you must adhere to when it comes to all of this being put together. We're going to create a story pole that's going to tell us different sizes of our headers, because headers are going to be 4x4, 4x6, 4x8, 4x10, 4x12. When there is a 4x10 or 4x12 header, usually up above, especially a 4x12, that top plate is going to be cut out completely because it's 11.5 inches. And most of the time, you're not going to have room for a 11.5-inch header in an 8-foot wall, 9-foot wall. You're not. Doors and window heights are standard until you get into custom framing of a custom home where you have somebody like, you know, Shaquille O'Neal or NBA player, 7 foot tall, 6'8". He cannot. 6'8", 6'10" is just the standard height of a door. If you're 7 foot tall, man, you're going to be ducking coming into your own plate. So yeah, they have to have 7-foot doors, 7'6", 7'8" doors to make it look naturally flow for them. Okay, that's custom framing. On your end for your plate, you're going to always have 3.5 inches in to receive another wall. Unless it's a 2x6 wall, then you must cut that back 5.5 inches. The width of the plate of a 2x6 wall. 2x6, 5.5 inches. 2x4, 3.5 inches. 2x8, 7 3/8 to 7.5 inches. When you get to 2x10, sometime it can go 9 1/4 to 9 3/8. 9.5 is trying to be a standard size, but when you come from the lumber yard, sometimes it's milled from the factory, the main place that mills everything down to its size. Sometimes it's not the same size, but you will get the same size lumber, but I have seen lumber where you had to rip it because one was an eighth of an inch wider than the other. And when you have those adjustments, especially for floors, I've seen floors get planed down before the plywood goes over it. So you have to make sure, especially when it comes to crowns, and we talked about crowns in our other video, when it comes to floor joisting. This is framing. So you have your studs, you have your bottom cripples, stud, king stud trimmer, top plate, double top plate. You got your header, top cripples, and you have your double top plate we just went over again. Now, the bottom plate. These are the channels that you're going to have on the end of walls. Okay? These three channels here. Very typical. This channel mostly is in between, inside of a wall. It could be here. It could be here. If there's a wall receiving here, this is where this channel comes into play. It's a 3-stud channel, but notice how both outside studs are turned the same direction, but the middle is turned opposite, because that's where the wall is going to be placed at, is right in between. And this stud here is for drywall backing, and this stud here is for drywall backing or drywall nailing. Okay? Corner stud, always typically be on the corner. California can always be on the corner as well. So it's the preference of the framer. There's a difference, like I said, between your 2x plate material grade and your 2x stud material grade. There's a big difference between those two. And you need to make sure when you do your lumber list, and we're going to show you how to do a lumber list and how to all your framing material. There are a lot of parts in the framing. Different types of framing material goes into framing. Different size lumber. You want your lumber and your lumber dropped off in a way that you can access to what's going to be put first. You're going to always have to separate your lumber on the job site. Plate material here, stud material over there, rafters and ceiling joists in another location. You got to have these things marked so you'll know, because a novice or an apprentice carpenter will go and say, hey man, go get me a 2x4. He may take a long 2x4 and you only need 6 foot, but he go and grabs a 12-footer. No. Let him know what lumber you're taking out for scrap or whatever you're doing for on that job. And your lumber should be sprayed and marked on especially large job sites. Separate, have everything in your inventory marked up so you'll know. Stud packages over here, plate material over there. So if you have a forklift driver, which I do drive as well, grad all, he needs to know where to pick up the package, or he needs to know where to pick up the lift of lumber. Most lumber comes in lift packages. Your plate material, your stud material. Your beams, you need to separate your beams. Your beams, there are different types of beams. We're going to get into that. Here, we're just dealing with framing. But now, on this area here, we're going to be definitely talking about how to tie your framing together and what walls require for you to have a 3.5-inch overhang and a 3.5-inch inset on framing. One to receive wall, one to extend over the wall to get nailed. There is a method to this madness on framing, and it's because how you want your walls to be locked in. You don't want to do a log cabin style. So here, let's pay attention to the top. I got double top plating. This is plating, and I'm using this area for how you want your double top plating. Because the top plate is going to be from stud end to stud end. But your double top plate is going to either hang over on one end, or it's going to be inset on another end to receive a wall. So I don't like log cabin framing for that, which means one end is long and one end is insert. I only use this as an example. But as you can see, this wall here with window B, this wall goes all the way from end to end. And I marked it because this is how it's plated. Pay attention. This is how it's plated. You don't want to run this wall over 3.5, and then this wall is shortened 3.5, and this wall has to lap onto this wall, and then this wall laps onto that wall. You see, over or lap. You want it to be over, which is lapping, or you want it to be in or butting on your plate. Your top plate either going to butt the next wall so that that wall is butting. That's going to lap and nail to that wall that is budding. So you're nailing on the top. So my top plate is got a horn. This area right here. It's got an overlap on both ends of the wall, here and here. Why? I've circled it here. I've circled here, circled. We're going to go through these circles so that you can understand and so that you can know how you want to plate and how you want your walls to be tied together. Now, if you do a log cabin type of plating, I'm not saying it's wrong, but I'm saying that when you go to plumbing line, there, for all neatness purposes, you want uniformity. You want things to look uniform. A lot of guys don't know how to do uniformity. Is that a word? Uniform? Yeah. They don't know how to uniform their framing to make it look picture perfect or just like out of a textbook. And I'll share some of the textbooks that you will need that will also help you out. I got some old school textbooks that they still sell. So, just so that you do know, this wall is running through. It has a horn that's lapping on both ends. Because this outside wall, both of these outside walls is butting into this wall on the top plate portion. But on the double top plate portion, this wall is short insert here. It's got an inset, 3.5 inches. Because this top plate has ran over to tie to this wall, and it has ran over on this side to tie to this wall. This long wall, these two long walls here are budding. You can see at the bottom, they're budding. It's in. And I'm only showing it on this side. It's in here. That line drawn across there is the plate at the bottom going from one end to another end so it can tie to this wall here. Tie to that wall. And your inside wall, check this out. On the inside, I want my inside wall here to hang over to tie to the main wall. It has to. That's a must. Because this wall is running through, but this wall is running too. It's running into it. So there's no framing or no double top plate that can catch this wall. Why? It's because it has one plate running continuously. But your plating has to be cut here, and it has to be cut on the other side here. Why? It's because it's receiving the double top plate that's going to tie this wall here into this wall. So there's some breaks. There's some breaks in my plating. Here and here. Here and here. This is a 3.5 inch break. Do I want it tight? Yeah. But do I need enough room? Because when I lift that wall up and put it into this pocket here, sometimes you don't want to have to walk the plate and beat it down because it's so tight. You want to just put it on top, move it over while you're looking at it at the top, and it falls right into place. If there's an eighth of an inch saw blade, that's all you need. Still tight. If it's too tight, 3.5 inches, you're going to have problems with that plate because some wood swells. And you got to remember that on a rainy day, overnight, you come in, your lumber has swollen up. It's waterlogged is what we call. And that's because the rain, it has absorbed the water. It means it has expanded. So it's going to be tight. Dried out lumber, perfect. It's good. It's going to fit. It's going to go right in. So this wall's running through. Now notice I have another wall here that's actually running through. It has a lap. It has a horn on it, which means the plate on this wall has been broken to receive this wall here. Like I told you, it's a method to this. Same as this end over here. It needs to lock and tie into this outside wall. It needs to tie here. It needs to tie here. I have a lap on both ends. I have a horn on both ends. I have a lap, a horn on this end here for this wall to receive. This channel right here is this one here. That's that channel that goes in this wall here. On this end, it could be a 3-store corner or it could be a California corner here. Either one of these two on the very end. But notice that I have this horn pretty much connecting to this wall here. So this wall is running through here. Why? It's because I want to lock this wall to that wall. Could I have locked this wall into this wall? Yeah, I could have. And it could have been in between. But I want this wall to be grabbed by this wall because I want it to lock it in. Same here, the horn. This is considered something like a log cabin here. Why? It's because the way I chose to plate it. It's the way I chose to plate it. I just wanted this wall, even though it's butting into here, I just wanted to lap over and tie that wall to make it all connected to here, instead of this wall connecting to this wall. Yeah, it's still locking it in. It really don't matter. I could have changed it, did what I wanted to do with it, but your framing, this is an interior wall. This is not a bearing wall. So whatever the plating style that you use, make it simple, make it plain. Everybody knows at this point in time how you should plate. A lot of apprentices don't know how to plate. They have to be taught how to plate on the job. And this is the planning stage. So when the main framer or the master carpenter or the foreman that's running the crew, if he laid this building out, then you're going to know automatically what plate, when you look at the wall structure or how it's framed from the layout and how the walls are snapped with your chalk line, he's going to tell you which one is a through wall, which one is a butt wall. Same here. There's a channel here. That's that channel there. Just want to make sure this plate should be going through at the top because it's connecting. I'm connecting this plate here. So there's a break in the plate right here. You see what I just did? I wanted to do that for you so you can see that this plate stopped so I can connect this wall here. There was no connection there. We need to connect it. I got this wall here. The plate over here is connecting to this wall, but it's also connecting to this wall here. So the plate here at the double top plate is connecting to this wall, which means this wall runs all the way to the corner, but the double top plate is what's running from here, from end to end. I'll unlock this whole entire corner in right there. So we went over plating. Same here. Same here. So double top plating is very important. And I need you to understand it. When you look at this diagram again, and you kind of go over it, when I show you on the framing model that I'm about to have framing showing you, should be this week. But I'm going to go over a complete layout of a building, windows, doors, and at the same time, how to estimate your lumber for framing, your headers. You need that. Then you're going to need your plumbing line material, which is mostly 12-foot 2x4s. 12-footers can be used later on. They can be used for drop ceilings, which is your soffits. Very good for drops. You're going to need drops in your kitchen. You're going to need drops in your hallways, usually 7'1" for your drop ceilings, which means after the drywall is hung, it's almost like 7 feet from floor to finish. There's a method to it. I want you to understand this whole entire method as we went over the parts here and we went over the framing members here for the window seals, the headers, the double seals, the king studs, the trimmer studs. All this is very important in the basic framing stage. Framing does get much more advanced because you got walls that's called rake walls, which go on an angle. They're framed just like at an angle. They got walls that are called balloon walls, which they are very high, maybe for an area in the house for stairwell. That wall, maybe it's going to be a 2-story wall. Balloon framing mostly is 2-story. That's a full 2-story wall. It's a double framed wall, but it's the length and the length of the total height of the house if it's a 2-story house. Same with chimneys on the inside. Most chimney framing goes all the way up on the inside to the rafters, the pitch of the roof. Okay, even on top of the roof, after sheeted, you still have to frame out a chimney area. We'll show you that on the model. So that way you can get the logistics of framing, period. So you can become mastery at it, because it's once you get it dialed in and locked in, then you will start knowing how you want to orchestrate all this here. I want to get you to orchestrate it. That means you're going to take control. You're going to lay it out. You're going to lay out all your windows and doors to the center or whatever the plans tell you. The center line, we went over that in another video, previous video. Remember about your bottom plate? It's got to be pressure treated or some type of treated material. And if it's just on plywood flooring, then it could be plating material, not stud grade. Plating material is usually number one material grade. Okay, a difference in 2x plating material grade and 2x stud grade. There's a difference. This is the area for your plating, and I just demonstrated how you want to plate things, how you want your lap walls, and how you want your through walls to have an inset for 3.5 inches or a lap of 3.5 inches. You have to remember those things. They're very important to tie your walls together. Usually, these are tied together with a man walking on it. Okay, he's split in between the corner, and he's bent over, and he's nailing that together. Well, how can he do that? Walking plate is a part of the carpenter's job. Doing it off of a ladder, a lot of guys will see you as a novice unless you're an older gentleman, you got bad knees or something like that. There's nothing wrong with that. Safety is always going to be the best factor in any job site. Safety, whether you're on a ladder, but when you're out in production, guys walk walls, hammer nail or nail gun on the side of their pouch, and they pop, pop, pop. They're nailing these corners together, and they tying these walls together. This is what you do before you plumb and align this wall, and how you straighten and make walls level, and how you sight a wall and make sure that the wall is not veering off and going crooked. You can look down the side of the wall, and you can tell when you have an intersecting wall here, if that wall needs to come in or out. We'll show you on the video. We're going to show you on our model. Stay tuned for a lot of things that's going on. We have a lot of things going on that's getting ready to take place with header sizes, cripple sizes, top and bottom, seals for windows, plates, layout. When we do the layout, we're going to also be estimating how many studs you need, how many channels. You're going to count your studs every 16 inches. You're going to use a method on the calculator is 0.75. That's the multiplication decimal for every 16 inches, 0.75. I take the length of a wall, and I'm just sharing this with you right now. 80 feet times 0.75 is going to tell you how many studs. Why is 0.75? What is 0.75 from decimals to inches? We're going to get into that. Same thing. Your stud's going to be 1.75 all the way around the perimeter, but always count your channels individually and add that to the stud factor. Always add your trimmer and your king stud for every window and door. Add that to the stud margin. You don't want studs to be every 16 inches and you miss your channels, you miss your king studs. These are added materials to your project. Stay tuned. Be prepared for what we have coming up next for you. Subscribe if you would like. I would like you to view these videos that I have in its entirety so you can get the full knowledge of it. This is a course where you want to, get the meat and potatoes. You going to school right here with Derek Seals as your professor and instructor for construction knowledge and carpentry. See you on the next video. God bless you and your family. Let's make some money together. I made some, still making some. Get your hourly wages up. The more you know, the more you're worth. See you on the next time. Bye.